So we've got a modelling question here. We've got a world human population in p billions is modelled by this equation. A and B are constants and t is the number of years after 2004. Using the estimated population figures from 2004 to 2007, a graph is plotted of log p against t. The points are approximately on a straight line with the gradient of that and an intercept of that. Estimate to 3 decimal places the value of A and the value of B, and they're from our original equation. So what I like to do before we do anything is take the logs of this equation. And there we are. We've got the variable t here, log b as a constant and log a as another constant. So here's the plot of log p against t. We're told it's an approximate straight line, gradient 0.0054 and an intercept of 0.81. Now we need to put these values back into our equation here and find out what a and b are. So looking at the intercept, this will be equal to log a, and the gradient, this will be equal to this term here. This is equal to log b, and yes, these are all log base 10. And if you work those both out on a calculator, you get that a is equal to 6.467 and b is equal to 1.012, and they're both to 3dp. And our full equation becomes that p is equal to 6.467 multiplied by 1.012t. And that's the answer to part A. So part B is really getting us to go back to what the equation actually means. In other words, the practical situation that this population growth has been represented by such a model. And we're supposed to interpret the value of the constant A. Well, A will be the population in the year 2004. And B is a measure of the population growth. And words to that effect will get you the 2 marks involved. So we need to use the model to estimate the population in 2030. Well, as this thing started in 2004, 2030 is effectively 26 years later. So we've got a sub, t is equal to 26. Our population is our expression, our full expression for the population, with t substituted as 26. And this turns out to be 8.9 million. And in D, we're supposed to comment on the reliability of this answer. Well, the figures only went up to 2007, and we've been asked to stretch this way beyond the data that was used to generate this relationship in the first place. So in a way, this figure really should be taken with the most enormous pinch of salt, because many things could have happened. And I've said the model only covers the period from 2004 to 2007, and 2030 is a long time after the results. So 8.9 million, the result that we've obtained through the model might be very inaccurate. But something like those words will get you the 1 mark available for part D. And that ends the question.